Thank you for joining us today. My name is John Proctor and I will be your moderator. Details of today's session are on the screen. This is the first session from the infrastructure domain and will be introduced by the chair of the Infrastructure Domain Steering Committee, Karin Anderson. We will then hear from Kazunori Takahashi and Sergei Muhik on geological and geotechnical modeling, and Paul Christian Max on global versus local georeferencing in large infrastructure projects. Jim Plume is also listed and will probably be speaking on roadmap working groups. The session is scheduled to last for 90 minutes, including time for questions. The session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to Karin, I'd like to remind you that this is a hybrid event. If you're online, your microphones will remain muted. If you wish to make a comment or ask a question, please use the chat box in the Ring Central app, and I will prompt you to do so. For attendees in the room, thank you for being with us. And if you wish to make a comment or ask a question, please raise your hand and we will provide you with a microphone so people online can also hear you. I need to bring to your attention the information that is coming on the screen now. buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent, and standards that are developed do not favour any particular provider but are open, non-binding and accessible to all. Please take note of our antitrust code of conduct. With that, I'm going to hand over to Karin.
Thank you, John. And I would like to start by saying thank you to the Infra Domain Steering Committee for giving me the opportunity to be their new chair. And I would also like to thank Tina for many years were you chairing the Infra Domain? 6 or 7. She even lost count. So I'm new to this and I hope I can do as good a job as Tina did. Oh, you want me to?
You can click as well
if
you want.
Yeah, can do that. And Tina provided me with a slide deck. I first did my own slide deck, but then I looked at hers, and of course I had to use some of these opening slides, like what is our mission and scope within the infra domain. And it is this part of our roadmap, or is it part of the? I'm just wondering which document this. It's in the roadmap. So that's the document we have. It's the document to go to know what we're doing as well. The mission is to combine, enhance, and develop open standards for intelligent data, which enable process and data integration for infrastructure. And I think that's what we've been doing for many years now. And I started in 2017 with the IFC road project together with Dr. Moon, who is here today. It's the first time I see him since we finalized the project. And we also have some other really important participants in the infrastructure projects, like Jim and Ronald and Sergei, and I can't mention all of them, and Lee. And so many people are here that were involved in those projects. And now we just have to make sure it actually also becomes reality in our administrations and around the world. And the scope is information exchange and process standards to support effective management of constructed built environment and linking and integrating across BIM and GIS. And when you see our steering committee, you will see we have a good representation from around the world and also from the GIS part of our life cycle. Here is the steering committee. This is it was during the spring that we had some new members and some members leaving us. And so we have a good representation from the US. They're very committed with their bridge initiatives and also road initiatives and GIS and everything else. We have Italians, which are also very forward-thinking in what they're doing. We have ACA Software that have been with us for many years in buildingSMART, also committing to implementing. So Italy is an important player. We have Sven from the Danish Road Directorate. And Denmark is also, they have the Femern Belt project. You heard about this in a few summits in the past. where they have been working together with buildingSMART representatives to create IDSs and a few others. And we also have Finland with Tina. You've been around for a long time. Marion, who was also part of the steering committee, she chose to only have one foot in buildingSMART, and that is now in the railway domain. And she was from the Finnish Transport Administration. But but we still have Finland in the steering committee. We have, of course, Jim Plume, long-lasting member. You were part of the beginning, you and Tina, right? Yes. And we have Michel from the French chapter, who was our project leader for the IFC tunnel project, and very active also during the infra developments, the IFC 4.3 developments. And we have Hiro from Japan, who is also brought a colleague here to present some examples from the tunnel project implementing that version of IFC. And we have Marek, who is from Autodesk, the UK. He is the chair also of the project steering committee. And Will is the representative for the standards committee, technical executive from our domain. Every domain in buildingSMART has a representative in the SCD. So that's us. How many of us are here? Could you stand up, be silly? Come on, guys. Jim. Good representation from the steering committee. Good. Thank you. This image, I think, was also created back in the days when we started looking at these projects. And we've been through so many developments to reach where we are today. And it's continuing. We still have tunnel that is going to be also an ISO standard, a version of the ISO. We published ISO 16732 with the IFC 4.3.2 version, including all these four, everything, but also including the bridge, road, rail, and ports and waterways. So that was published last year in 2024 in ISO. So we're very happy with that. Now we are looking into what the next steps are, apart from tunnel. I'll talk about tunnel in the coming slide. But now we're looking at how do we speed up implementation? How do we get now the benefits that we have been so longing for? So the tunnel project status is the project is closed. The stakeholders are pleased with the delivery, right, Hiro? We are both stakeholders in this. I don't know if we have any more tunnel project stakeholders in here. No, we have a few participants, I think, though. Yes, Chi, you're smiling. I can see you. So we've said that the delivery is what we were expecting. So and now the Infradomain Steering Committee has requested that this documentation is published as a candidate standard, similarly to what we've done with all the previous work. So these all of these, the documentation from those projects, from every stage of the project, is actually documented on the buildingSMART homepage under infrastructure domain. So that's what we want with the tunnel project as well. There is also a plan being worked on by buildingSMART for submission to ISO. I think Sergey is going to give us even more update in a little while. And the dialogue with ISO has started. And on my way up here, I met Øyvind Roth, who is the chair of the ISO committee and also the SEN committee with regards to BIM. And he said, now I have requested to get that delivery to us. Who is sending it to me? So that's really good. They are ready to receive it. And this is the last slide. I don't know if it's still correct, Sergey, but it's what we've been told now. This is part of the plan. It's not just what was produced during the tunnel project. It's also some postponed comments that came from ISO during the previous publication. And there are also some fixes in an open GitHub repository. Maybe someone here has provided some feedback to it. It's with corrections and changes that are needed. So there's no time set to this yet, and I cannot really say any more than this. This is what we know about the plans until Sergei gets the microphone. And there are quite a few objects in all these three sets of data. So that's the tunnel project. Now we are also focusing, we have some focus areas that are defined in our roadmap. And Jim is going to have a session on the roadmap development. Is it this afternoon, right? 4 o'clock here in this room. And we have sent out a questionnaire to the steering committee members, and I think we will be sharing that questionnaire with this public as well.
Yeah, we will.
Yes.
Yep.
Yeah, because we need help to prioritize, and we had a So we have this roadmap that will then be presented this afternoon, and we have a few working groups within the steering committee. And the roadmap was developed within the community, right? Jim, I'm looking at you now. It was during, my colleague Anna was part of that, and the steering committee had this bigger workshop, a series of workshops in around the organizations to develop these prioritized activities. We have a collaboration with other domain and initiatives. We have a joint session with the railway domain. Is it tomorrow? Tomorrow, where we have a couple of presentations. We have the BIM and GIS initiative that is being led by one of our steering committee members, Mark Goldman from Estrie, and he's doing that together with several other domains. So that is one of the initiatives that's sort of in all of buildingSMART domains, basically. We have a focus area that's IFC tunnel that's going to go to ISA. We're not going to stop talking about that one. And we have a new initiative that is within our domain, that is the Open BIM for power transmission and distribution. And there is a session on that tomorrow. Yeah, it's one of the shortest sessions in the morning. Yeah, and Jim will participate there if you're interested in that one. And so that is one of the projects that is starting now within our domain that will continue reporting on, of course. And we also have liaison updates from other standardization organizations and working groups. We have several of the members in the steering committee are also part of standardization organizations like CEN and ISO. And here, this is basically what I have to say today. I'm going to hand over to a couple of other presentations. Yeah, I won't be here this afternoon. Sure. I'll just. It says 2, 4, 3. So session 2 is this afternoon, and it's on the roadmap, and you won't be able to participate because there's a clash in the schedule. We have session 4, so I've written them in this order because session 4 is actually before session 3. And session 4 is this 9 to 10:30. It's within that. I don't know which slot they have that, or you have.
I think it's 10 a.m.
10 a.m.
I think.
Okay. So you don't have to listen to all those topics that are in that open session. It's a multiple topic session. And then we have these 2 examples, this joint session with the railway domain, where the chair of the railway domain is coming, Eivind Pagander, and Alexa will present some examples from the US. So welcome to the infra domain session number 1. And I'm going to hand over to Alexa then to say a little bit about your working group.
There was a 3-slide
Yeah, if Alexa could start, I'll see if I can pull up your slides, Alexa. But you're happy to go without the slides for a moment? Yep.
Yeah, that's fine. So my report is going to be a little brief. So the working group that I was leading was the development of a white paper or guide for IFC implementation from a practitioner perspective. And we had a working group and we met a few times to talk about the type of content we wanted to put in that guide. And so very quickly we realized that we were starting too soon without project examples, and that for us to do it justice, we really needed examples. But the purpose of, oops, I collect something. Can you bring it back up? Oh, there we go. Okay. So the IFC for Infrastructure Guide is the official name of the paper that we had been wanting to publish for quite some time. And it really was meant to be a best practice for our users. And we wanted to talk about things like what should we be using IFC for and what is not appropriate to use IFC for, right? So kind of educational. And the primary audience was the infrastructure owners and practitioners. So that was the original ask. The topics that we were thinking of incorporating into that guide were proper use of IFC 4.3, foundational concepts on the structure of IFC, specifically IFC classes and predefined types, spatial containment, and those types of things that most engineers are not familiar with in the infra domain, what we found out. And then how to work with a standard within the context of a project delivery. And that was the area that we realized this guy would be much better if we had some examples from around the world to use for creating the content. And so we paused on the development, and we are now we're going to be collecting project examples. So if you have a good example in your country, we would like to talk to you. So what we need to do now is identify new members for the working group. We want to have a lot of contributors, but probably a couple of authors. That way that the paper has one voice. But we want to figure out those roles and responsibilities moving forward. The examples, we can't not stress that enough. That's very important. And we hope to have a lot of this by next summit. So a lot of the examples by the next summit. I don't know that the white paper will be ready but the examples will be collected. Yes. So, and that's my update.
Sure. Do you have my slides?
Impromptu.
Yes, indeed.
I sent them through, but there's no name.
Well, while you're getting the slides ready, I'm Mark Goldman with Esri. My day job is to promote GIS in AEC, and I don't know, maybe it's my evening job with the IDSC is very similar. So I've taken on the roadmap item, which is the BIM and GIS interoperability. As Karin mentioned, across buildingSMART, that topic is peppered throughout. So I've been working with Jag Malala from WSP, Eric Poirier from École de Technologie Supérieure in Montreal, and we've been herding the cats, as it were, across buildingSMART, various domains, collecting use cases, collecting user stories, working towards potentially and eventually creating use case management entries so that the implementers have a common reference point to use when they work on BIM and GIS capabilities. We've had, I think, 4 of the 10 buildingSMART domains contribute user stories. We've synthesized those together to come up with some high-level use case categories within each one of those 5 categories that we identified through work at the Valencia Summit, the Singapore Summit, and a little bit at the Morocco Summit. We are holding a workshop today at 4 o'clock, so that's why I won't be here for the ID2 session. We've also been collaborating with OGC, the Open Geospatial Consortium, who are the purveyors of GIS standards. They have several working groups focused on 3D, on BIM, and their efforts have contributed to our efforts in helping us identify these use case categories and the specific use cases.
You're on the list, Mark, but I don't have your slide.
Let's see if it pulls up here. Nope.
No.
Okay.
I thought I emailed you.
Okay. It's okay. I can talk through it. Let me just go back to, we've compiled, like I said, 5 use case categories. Within each one of those 5 use case categories, we have 5 specific use cases. The workshop later today will be hopefully a room of about 80 to 100 people who are going to work on identifying gaps in those use cases. Who are the actors in these use cases? What are the challenges of implementing those use cases given the current status? What integrations would be required to be able to, what changes need to be made? And all of that input that we'll collect today will then become a starting point of the use case management system entries. So we've been at this for a couple of years. The specific roadmap that this task is working on is the roadmap that OGC and buildingSMART have agreed upon collaboratively. So within the Infrastructure Domain Steering Committee, we've taken on the ownership of this much larger task that is a cross-buildingSMART and cross-association effort with OGC to enable a clear understanding, a set of documented use cases with work process diagrams, exchange requirements, everything that's in the UCM tool, so that BIM and GIS can be delivered.
So I'll wrap this up. I'll be convening the roadmap session this afternoon at 4 o'clock, and I beg you to come if you possibly can, because the more people we have and the more interaction we have, we can plan. It's actually a mid-progress one. We've already got a roadmap that takes us to the next 2 years. We're halfway through that. So this is really an opportunity to review what we're doing and what other things should we be doing or need we to do. And I have no preconceived ideas. All I've done is document it, and I want your input. So after I've talked for 10 or 15 minutes, if you have nothing to say, then it'll be a very short session. It's really what I'm saying. Thanks.
And we're competing with Mark's.
Yes. And so both Alexa and Mark had to do offer their little bit this morning because they can't come this afternoon. So it's all a bit complicated.
So I think we're going to move on to our next presenters.
Yeah, I think we will. Thank you, Karin. Thank you to the various members of the Infra Domain Steering Committee. We have 2 presenters now, Kazunori and Sergey. If you could take the mics while I get your slides up. Thank you.
So let me maybe give the introduction here shortly while we're waiting for the slides. Both Kazunori and I were part of the tunnel project. So from that perspective, we are presenting today an actual use case of the developed schema. And we will also be giving an update on a couple of important, let's say, discussions and conversations taking place already in this summit, which is an amazing thing to actually be able to now live give you an update of everything that was happening already in the summit. So this just gives a great incentive for everyone to join these summits, because all of the conversations that take place, these are actually real life decisions that really require this interaction with the people involved. So and let me also maybe give a shout out to the IDSC for being persistent on the actual deliverables of the IFC tunnel project, and going through all the obstacles that were, of course, in every single
He has the clicker.
Sure, yeah. I'm not yet done with the first slide, so thanking IDSC for all the energy and, of course, the will to carry this on. And now we're actually at a point where we can give some announcement. But let's maybe go to the start of the presentation, right? So Kazunori, as one of the stakeholder representatives, was kind enough to look at our documentation, look at our deliverables, produce a file from an actual real-life use case. He's not the only one, of course. We also had the French participation, who provided a real-life tunnel project, which we then converted to IFC 4.4. We'll also be showing that one, by the way. But first and foremost, let's have a look at what we produced. So the tunnel project was launched in 2019 and it was delivered in 2024. There was a lot of back and forth. It could have been delivered sooner, but it's a work in progress. So we managed to do that. However, we had 3 main scopes in excavation, systems, and geotechnics. We gathered the entire 5 years of work in this one entry point with the generated documentation. It features a changelog. It features all of the requirements analysis reports, the BPMNs, and so on. So everything's available on this site. We also have a QR code there to visit if you wish. And this is the single entry point for whatever was produced and whatever was then implemented. As I promised, there's also a changelog, a detailed changelog. There's actually another, even more detailed changelog than this that actually goes into the schema changes and so on. But for an overview from the stakeholder perspective, this is what you can see. We extended many of the sub-schemas. As you see, we even extended IFC kernel. So we were actually in all levels of the IFC specification with our work. We added predefined types. We added property sets. We added a lot of content that we also then marked according to the request of buildingSMART International and marked it into buckets. So ABC were buckets specified for a more easier interaction. Although it is available in the sub-schemas anyway, but apparently this worked. So glad to have done it. We marked all of our changes with these buckets. The first one being the one that interacts the tunnel extensions to other schemas. Then we have tunnel-specific extensions and we have core extensions. So 3 categories here. Again, if you wish to, visit the link. It's a full list. It's not just entities. It's also properties, quantities, model views. So you can inspect all of them. The real highlight of the project, however, was this deployment program that we started. This is also where Kazunori will then have a really nice presentation of what we achieved for the Tokyo environment. But let me not steal your thunder there. In this deployment program, we actually went from the basic implementer requirements. So we really wanted to onboard as many implementers as simple as possible. So we didn't just focus on what we produced new. We also gave an introduction for every implementer how to set up a project. So what do you have to do to have a valid IFC project? From the point of view of having units defined, declaration of concepts, of templates, of property set templates, assignment of geometric representation context. So it was a real boilerplate how to set up an IFC project, an IFC file, so that anyone, not just infrastructure implementers, can use this and actually build an IFC file properly. It then went into the next level, into the IFC project breakdown, meaning that how project structures can be defined, how elements are contained in these project structures, how actual physical instances are connected to typing, and so on and so forth. This was the second, still in the scope of the boilerplate, so any implementer can use what we produced here to actually create a proper and valid IFC file. And only then, once we had all of this set up, we went into the domain-specific implementation. So from here on, we could do the same, for example, for buildings, set up tests, set up requirements, and allow them to be implemented. So it's actually a guidance of how to, in a nutshell, it's a guidance how to serialize an IFC file properly. We also set up tests with automatic reports. It is still all available. Unfortunately, we were using a free GitHub account, so certain reports have been deleted by GitHub. They do not host all reports if it's a free account. So, but everything can be reproduced. It's all there. It's a setting for IFC where tests have driven the development. So it's a very, very interesting architectural approach of how to develop standards. We were doing this in 2024. And we also produced an annex with the entire guidance, with all of the files that were produced in the scope, with all of the documentation, so how software vendors interacted with the project team, with each other, and so on. All of the test files are available there. You can download them, look at them. We also have some implementers here. Of course, I see Eric. I see others who were participating. I think you'll find that your files are published here. They are all tested. Esri also contributed, so thank you, Mark. Only at the end, but it's the file is documented. It's a really nice implementation, so that we can also see tunnels in Esri. We will also show the file, by the way, afterwards. But the announcement comes now. So this is actually the slide doesn't say all the truth behind it. These are the talks that we had in the last 2 days. What do we actually do? What is the plan? Karin talked about the plan. Now we have one. The package for the candidate standard will be these deliverables. So it's still open until the vote is done. Everyone is invited to contribute, from buildingSMART members to buildingSMART chapters. Everyone's invited to contribute. It's still there. We can track any issues on GitHub. It's a system set up where we have the project from the backlog all the way to implementation documented in a project. It's basically a Kanban board, but it's automated. So please look at it. If you have any feedback, give it to us. The GitHub is set up. We will follow the buildingSMART process with the vote for the candidate standard. We will go for the vote on the technical executive steering committee, standards committee, for the executive standards committee, and then finally, once all is agreed and specified, for the SC vote. All of this will then be as agreed, prepared, and sent to ISO. The talks with ISO are also on the way, but this is what Karin already said. The thing is, the bottom line of this, we have a plan. It's now implementation time, so feel free to contribute. it's still open. And I hope everyone's happy with this. I think this is the goal. I think this is good news. It is actually something that has been agreed and approved 1 hour ago. So yes, that's how summits work. Glad to be here. Glad to be able to do this, and glad to announce this to everyone. And now let's go to the actual interesting part.
Thanks, Sergey. So I'm with the Japanese consulting firm called Oyo Corporation, and we have been involved in the tunnel project from the beginning. And also we participated in the deployment program. So we learned basics, and but we wanted to test with a little bit more realistic example. And yeah, we had this project to make geological, geotechnical models of central Tokyo, which will be used as a basis of hazard maps, like this example, which is prediction of liquefaction in Tokyo. So the modeling could be challenging because of the complex geology in this area, but we thought we could test IFC Float 4 within this project. So this is the area of interest. This is the central part of Tokyo, which has the very dense structures like high-rise office buildings, government buildings, luxury apartments, and embassies. And yeah, actually also right outside of this area, this stadium was where the World Athletics Championship took place last week. So it's really in the middle of Tokyo. To do the modeling, we collected some source data. These are the boreholes we used. We used 235 boreholes in this area from these sources. Also, we used approximately 50 geological sections in this area, and all these data are publicly available. And first, we put these source data into modeling software, and then we got this model first. Well, actually, just data. These are the geological sections, and these small black lines are boreholes. And based on this, we came up with this geological layers as a solid model. And based on that solid model, we created both a model of soil classification and also the distribution of N value, which indicates the stiffness of the ground. So at this point, those models are in a commercial modeling software, so with the proprietary format. So they are not IFC yet, but we try to encode those models using IFC Float 4, which was proposed by the tunnel project. It's because we found that IFC Float 3 doesn't really have enough entities and properties to represent geological and geotechnical data, models, and also objects. So if we want to do it with IFC Float 3, then we need to use quite generic entities like IFC building element proxy. So if we do that, then we need to use arbitrary text description in the code and also use a defined property sets. So we can do this and we can exchange model, but when we do that, then we also have to provide user-defined specifications to make the other parts understand. So even we provide user-defined specs, the commercial software is unlikely able to fully understand the model by default because they are user-defined. So we thought that IFC Float 4 can sort this problem out to some degree because they have more entities and property sets developed specifically for geology and geotechnics. So we used IFC Float 4 and then encoded the model using Float 4. And this is how it looks like on RDF IFC viewer. Well, you can't really see the IFC, but this is encoded using IFC. And this model contains the boreholes, these lines, the geological sections. You can't really see it here, but there are some sections, and these are the source data. And also the geological layers that you are seeing right now. And also we have voxel models. And Sergey, you want to explain this?
Yeah, so let me go for this. Of course, the first step is defining the entities. That's sort of giving you a framework in which you work inside IFC, as it is in any data model. But then there's a layer on top, because we are developing foundation classes. An example, IFC wall, for example, if you take an IFC wall, it's like it can be a partitioning wall, but it can also be a retaining wall. Completely different concepts, but the same entity. So how do you achieve that kind of a granularity and detail in IFC? Of course, you have to have the basic models. If you just use building element proxy constantly, the semantics are not there, and all of the attached concepts are problematic to interpret. So what do? Once you have the basic models, you have to put them together, and there's this in this example that is of course not all-encompassing of the specification, but we sort of tried to give a breakdown of how in IFC 4.3 and in IFC 4.4 these concepts can be used to provide better definitions and better data structures. In 4.3, there was a basic borehole as a composite, and it was decomposed into building element proxies because there was no actual way of defining the parts. This was then in IFC 4.4 can be modeled with geoscience observations. So you can get an additional layer of semantics on top of borehole by actually using an entity designed for it, and the relationship between them covers the observations on IFC borehole. And similarly on the breakdowns of geological sections and layers, we have introduced new entities and their breakdowns, and this was already possible, as it always is in IFC. Using IFC building element proxy, you can basically build anything, but where are the semantics and where are where's the framework of how to implement different concepts on building element proxy? They're not present, so you do not have a way of actually validating your files. Therefore, all of this is also encoded, and with the predefined types that were added to these entities, we could actually then specify how exactly certain breakdowns, certain compositions are supposed to function. We also went further with this, with the IFC 4.4 requirements from the requirements analysis from 5 years ago, and added concepts in the kernel, in the resource layer of IFC. And one of them, for example, which is, I don't know why, but it's apparently very controversial, is voxels. It's an essential part of how to exchange geotechnical data in the industry. So why not support it in IFC? We did this completely from scratch, defined the geometric representation for the geoscience elements, the geoscience models, and in combining the voxel grid geometric representation, so for visualizing, and voxel data as a property set for many indexed. If we break it down, it is a property set for many indexed elements at once. You put the values directly on the small voxels. You can actually visualize data, and Kazunori has already showed how he can color things according to this data. We can also continue with other examples. I think we have a lot more.
Can you just say what a voxel is? I know what a voxel is, but maybe someone doesn't know what a voxel is.
Okay, so a voxel is a way of representing geometry with small, discrete cubes, basically. So it can also be something else, but in principle, it's a cube. You put them together, and you have a 3D representation. You do not have a boundary representation where you have faces, but you also know what's inside, which is very important for geotechnics. Obviously, you have to know if you cut somewhere, what is actually in that discrete part, and voxels allow that. It has to be. Typically, these grids are very ordered. The same size of voxel is in the entire volumetric representation, and the way this can be defined is just defining the dimensions of one voxel, then taking a coordinate system and going through the coordinate system through this voxel grid and assigning a value, whether a voxel is present or not, and then you can visualize. I think it looks pretty.
Yes. So yeah, we'd like to explain a little bit more about the data model in that geotechnical model. So now we have IFC borehole with the newly defined predefined type core drilling, and this is contained in the IFC site. And we have two geoscience observations. One represents borehole log, the other one represents in situ test results. And the borehole log represents the the actual borehole log, and this is in situ test result has the data about the SPT test. This is a kind of measurement. So we can have two different test results within one borehole using the parent level geoscience observation and also the child level geoscience observation. And the child level can be multiple, so those child level geoscience observation represents each section of the borehole. So if I explain it graphically, this child level geoscience observation represents these individual sections, and the parent level represents the whole borehole. This is how it looks like in the code. This is the borehole, which has the geoscience observation. This is the parent level, and these are the child level. And do you want to talk something about it?
So, as you see, Kazunori has a wonderful talent of providing these nicely colored direct connections to the actual model. This is the end result, however. Before we get to there, we need to define how these concepts inside IFC are supposed to be structured. This is done with the usages, and if I give you a very simple example, it doesn't make any sense to have a building story decomposed into buildings, but it makes a lot of sense vice versa. So this is one of the usages, how you use IFC building. You use IFC building and decompose it into stories, but you do not use building stories and decompose it into buildings. This is what usages are. There's a generic ISO concept template saying that you can spatially decompose the IFC project and the spatial structure elements. But in order to get to the logic that so nicely and colorfully Kazunori showed in the previous visualization, is you have to define this rule. And what we have here, you can also do it on predefined type level, by the way. But what we have here is how do we compose observation? An example of how to compose observations, geoscience observations, and then assign them to the entities. So an observation as a concept is a separate object. It's an abstract object. It doesn't actually visualize, but it holds some data, and that can be used on borehole, on spatial zone, and on IFC sensor to assign certain metadata to this concept. It works sort of like a property set, but because it's an IFC object, it is also extendable by property sets. This is all encoded then in the ISO specification and can be used inside different frameworks. So BIM to GIS, of course, being one of the use cases. It is all in the eye, so it can be used, and software vendors can actually make a lot of benefits or get a lot of benefits from such definitions, because all of this is also testable, and it's also documented in the IFC deployment project where we tested exactly these concepts.
All right. Then next, the data model for geological sections and layers. Well, pretty similar structure. We have geoscience model with a predefined type geology model because it's geology model. And this is contained in IFC sites. And we've got some geoscience features with geological units. These geoscience features represent each layer of the model, and they are aggregated into the layer model. So for example, this green layer is one geoscience feature, and this beige layer is another geoscience feature, and they are aggregated into the geoscience model, which is the whole geological section. And same for the layers, the solid layers. This light green and dark green layers are each geoscience features, and they are aggregated into the whole solid layer model, which is represented by IFC geoscience model. And this is how it looks like in the code. Yeah, same thing, IFC geoscience model here, and this is contained in sites. There are two geoscience features that represents each layer, and they are aggregated into the geoscience model. And
now the boring part again, yes, how is this documented? Each geoscience model has a concept assigned to it. It's called geoscience model decomposition, and it's restricted that the geoscience model can only be decomposed into geoscience features or geoscience or other geoscience models. You cannot decompose a geoscience model into IFC beams. Makes sense. So why not document it? And the domain knowledge, this is how the domain knowledge then flows into the schema. We can also write descriptions of what this actually means. So yeah, that's what we did.
So, and this is how it looks like for the voxel. We've got IFC spatial zone with newly defined predefined type mapped zone, which is again contained in the IFC site. And we have IFC geoscience model, which is assigned to the IFC spatial zone. And the geometry of this geoscience model is represented by IFC voxel grid, which defines the voxels, the geometry of the voxels. And the actual data in these voxels are defined by these IFC integer voxel data. In our case, this is for n values, and IFC label voxel data. In our case, this is for soil classification. And they are aggregated into the geoscience model. So it's a little bit difficult to see, but so this voxel grid defines not only one cube, but the geometry of a whole voxel model, how many voxels we have, or how large the one voxel is, and so on. And these IOC integer voxel data, integer label voxel data, or IOC voxel data in general, that gives the data to all these voxels. This is how it looks like in the code. We have geoscience model here, and the geometry of this geoscience model is represented by this voxel grid. And these IFC integer voxel data, IFC label voxel data, provides the data. Again.
So in order to then write a proper specification for it, we say that only geoscience element is the only entity inside the IFC specification that uses voxel geometry. For now, this was the only requirement, meaning that any software vendor implementing IFC does not have to implement voxel geometry, only the ones that actually support stuff like that. So, and in order to do that, again, we defined the usage. We said voxel geometry is only on geoscience element, nothing else, which makes it clear if you're using IFC geoscience element, you should be using voxel geometry and not otherwise.
To summarize, we made a geological and geotechnical model of central Tokyo, and we encoded the model using IFC Fold 4 extension. That was kind of testing IFC Fold 4, and by doing this, we could see the entities and the property sets we proposed in within Tunnel project worked. And those entities and property sets are proposed by domain experts based on the accuracy and the relevance. So they are very important for us. And using IFC Fold 4, we can now have comprehensive geological data, geotechnical data within the model, and it can retain all essential information for the user of the models. We can also test that voxel model, and then we saw that it works. So that it allows for further analysis and visualization. So using IFC Fold 4 makes it simpler and easier to exchange information for geotechnical analysis and evaluation. And as you saw, and we experienced that the IFC Fold 4 extension is useful for geotechnical projects, but I'm sure that Fold 4 is useful for many other projects as well. And now, I don't know.
Final word. So, final word. You have all the QR codes, the links inside. Please visit the sites. Please comment. This is the time to do it. Once the SCTE and SE votes are done, this is what is going to go to ISO. Now is the time to give your feedback. As you have seen, at least for geotechnics, what we showed here, it works. We have other examples which can be downloaded, thanks, of course, to the French authorities to provide us with the IFC2x3 file, which we converted according to the rules that we saw here. Thanks to Esri, of course, for testing the file, which they visualized so nicely. And thanks to all the other software vendors that participated. I hope it was a good experience for you as it was for us. I hope we could help you implement everything that we agreed on and that we tested is documented. Please use the boilerplate. We will talk to buildingSMART International, to the local chapters to distribute the documentation. I think by now it's clear that the work done was amazing. So get in touch with your software vendors. There's a clear way of how to define IFC. It's not magic. It's a very technical thing, and it's all checkable, and we should use it. Thanks.
Thank you. I think Alexa now got some really good input for her guideline, right? You've got a good start there. Yeah. Thank you, Sergey. Kazunori, sorry. That was a very good presentation. Very good to see that it works. Right, Hiro? We're even more pleased now, right? And she. Okay, so we've said in the Infradomain Steering Committee that at every summit we need a presentation on geographic placement. Is that what it's called? Georeferencing, yes. We need to keep talking about this because it hasn't been such an important topic maybe for those building houses and buildings, but for us in infrastructure it is absolutely essential. So we had this paper submitted to buildingSMART in the call for papers, and it was Paul who had this as a topic. So welcome, Paul, to talk about georeferencing.
Thank you, Karin. Hello to everyone. I think it's, I need this slider clicker. Thank you. Yeah, as Karin mentioned, the topic of georeferencing is always a bit tricky and always a bit, well, complicated and complex for engineers in the BIM world especially. So I thought could be nice to talk something about that today. And how does it work? Okay, this is my contacts. If you have any questions afterwards, so I'm from AFRY. It's a Swedish company. We are quite big in the Scandinavian countries and working quite a lot with Trafikverket. So in Germany, we are not that big, like you see here, but a few people know us as well. With Deutsche Bahn, we are working here, same as in Sweden, but yeah, that's our company. So why georeferencing? I mean, thank you. Last week I was in a conference in Gießen, and then I learned that, if I remember right, is it my fault or is it yours? So I don't click anything, sorry for that. I have learned that 85% of the data are linked to our world somehow. So they have a georeference information in it. So I think any data we produce should somehow be placed on a globe understanding in a georeferenced way. And, well, I don't know what to do, where to click. Can you help me? Thank you. Yeah, the key is the location. And location is the connection between BIM and GIS. So when you place your BIM model, what you have designed in a good way, even voxel data, you can place it in an environment in the surrounding GIS world on the globe somewhere. And for that, you need a location information. And in the past, we have done that by maps. So we tried to make the curved earth, use it in a flat way, because it's easier. Paper is flat, you can draw on it, nice way, but still flat earth. And, sorry, well, something is missing here. Usually was written CAD. So we are coming from the CAD world in 2D, and now we are moving, or we have been moved with the height information to the BIM world, and we called it 3D. But it's not. It's 2D times plus 1D. So it means it's still flat. When I noticed that, I was a bit surprised, and I thought myself, I was studying as an engineer, a lot precision, surveying, whatever, how to design everything, and then I learned what we do is something old and something wrong, maybe. Because when you're working in a georeferenced system, it might be distorted somehow, your data. Oh. The GIS world can deal with anything. They have no problem. They can mix it. They have just coordinates to organize. That's no problem. The BIM world can deal only with scale 1. It means no distortion. So, but they're thinking on a flat earth. So they think the length is true. And if you place it in the GIS, in the real world, then suddenly something happens. Then you need to decide. Either you keep the coordinates or you keep the length. You cannot do both. That's the problem. You need to decide, what should I choose? Should I choose the bridge in total by the length? But maybe the coordinates of beginning and end point is not the same what I planned before in the real world when I built it. Maybe it's not a big problem. Maybe it's just a few centimeters, so less than the the precision on site, what you can do. And even to know what you should do with a model, you can now place into IFC. It's IFC 4.3 when we have added, or the buildingSMART has added, the colleague Stefan Jaud was, I think, mainly involved in these projected CRS map conversion entities what have been added to the IFC models. They come from the building, the house address is not very precise. You have a site address, might be preciseness of 100 meters. Then they move to latitude, longitude, elevation. It's a bit more precise. Then you have a point. And then, well, it's Christian Klemen, a professor of Dresden, has invented these LO georef representation and definition. So you can use it for your scope of work and the documentation, what you expect the modelers to deliver. Say, well, I want 20 or 30, whatever. But for infrastructure projects, there's no question you need 50, always. Otherwise, you are lost somewhere on addresses, and that's not enough. But what does it mean, the entities? You have an old drawing, and I think, any one of you knows what you did, like you typed in an address, you typed in a coordinate system, some local placement, some cross of the grid, an northing arrow, whatever, height information. And now you can find those information in IFC also. That's the only thing what the entities provide you. That because you don't have these symbols in BIM anymore, you need it in a machine-readable format, and this is what the entities provide you. So that's the solution of IFC, and I think it's quite reasonable. It's the same, just different. This is what I already mentioned. That level of GeoRef 50 is needed for infrastructure projects. Here you see examples of Germany, like Deutsche Bahn. We have the DBREF system, the big one for the whole country, or local systems for any station. It's a specialty in Germany. I will come to that a bit later. And also one information could be interesting, that in IFC, when you click on the model and you ask for a point coordinates, the viewer might give you a number, X, Y, Z, some billion meters, whatever. But this number is not written in the IFC file itself. You cannot search inside the IFC file for this number because it's a calculated number out of a lot of pieces. That's hard to understand, I think. And who knows that? You need to go a deep dive into IFC. I hope the viewer will help us to explore that a bit better. But just for us, it's important to know that it's a calculated number and not a written number inside. Just the point for now. And level of GeoRef 50 is not that easy at all, but you have three ways to define your IFC model. There's a way, the standard way, what we did in the past, IFC 2x3, 4, whatever, we use that address. You see, we have the projection on the top of the slide. You see the map in background. Map means we project, we make a flat Earth out of the cube, the sphere. And this is where we place our models, the BIM worlds on the right side, via a kind of representation coordinate system. We place it in a projected way on the globe. This is the old way. So we we don't change geometry, just place the point. And then IFC 4.3 gives us a bit more possibilities. So now we can place our BIM models directly without projection on the globe. And yeah, then we have it one by one without distortion, maybe. But because the BIM tools, they don't care about distortion or scale factor. So if you say the top way is rigid operation, and rigid operation means not just the reference point has been moved to the globe, but any point of the model. What does it mean? I told you, you need to decide either coordinates or length. Whatever you want to keep, you can place it. When you place this one, you keep the length. If you place this one, you keep the coordinates. There is no right or wrong. It's just, it depends. But you need to know that you have the possibility to do that now. Just a question, how many of you know that? That's good. More than I expected, but you are experienced audience, so no surprise at the end. But this is important to know. And the people who expect deliveries, like clients or customers, whatever, from designers, they need to ask for that and to tell the people, please deliver me in the right way. We did a test, just 70 kilometer cube to make it visible on the globe to get an understanding of that. 70 kilometers because BIM Collab Zoom was able to show 70 kilometers and not more. I don't know why, but it was the limit. And then we stopped. You see here the point reference position. What does it mean? The length is still the same, 70 kilometers, but there's a gap. The coordinates are not right. And here we did not, I mean, something less than 70 or more than 70 kilometers, but no gap and the curvature on the globe surface. Decide whatever you want with the elements and the models, you need to decide. You can just choose one. But because of new entities in IFC 4.3, there are some gaps in the old versions 2x3 and 4. And because, you know, not all tools can deliver and export in a sufficient way, the IFC 4.3 right now, still, so we thought there are some recommendations for the old version. It's an EPZ called like the entity, EPZ projected CRS and EPZ map conversion, but only those two entities, but we have 5 in IFC 4.3 and there are 3 left. It's a gap in IFC. And so Stefan Jaud and me, we have just published a paper we will show in 2 days to the audience that we propose also the EPZ definition for those 3 missing entities, that the software tools on the global level can understand even georeferencing information in the old IFC version 2x3 and 4 in a standardized way on the whole world. That would be nice that you take it with you. And I mean, whoever is working with georeferencing in the BIM world and dealing with big coordinates knows that problems, I mean, they're solvable. It's not a big issue, but we are confronted with that things. It's just to make it visible. Yeah, and in Germany we have specialty like local systems for any station. We have 9,000 stations in Germany, so we have 9,000 station coordinate systems to deal with. That's the local solution, and but also we have kind of global reference system for it's 2 different Deutsche Bahn business units, so they care in a bit different way. Maybe it will merge in the future. I hope so. That makes it a bit simpler for us engineers. And here you see the difference. Here the meridian and the stripe is quite wide, 3 degrees, and here it's just 10 kilometers. So less width, less distortion. That's an idea to get the reference system coping with the problem that the authoring tools cannot deal with scaling factors. They just have one. And this is more to one than if you are here on the edge of this stripe. This is the idea. But for big projects, you have the problem when you have one system for each station, then you need to coordinate models from different coordinate systems. And this gives us a lot of problems. You see, you have, it's German, but you see just some points are green, what was red before, but other points are red, what was green before. So you solve a problem, but you create new problems, and that might be to thought through again. What does it mean, the distortion factor? You see here, the big, in another way to show the big reference system of the whole country is a bigger scaling factor, less precision, and the other VA system for the station has less distortion, but a higher precision for a bigger IFC file. And just comparison diagram from Stefan Jaud from his PhD thesis. And here I compared the solution with, when you have it for each station, you have a lot of problems. And if you use the big one, you have some problems still. But the recommendation what we give to the projects might be obviously, but it's not in Germany, to choose one system for the whole project. Then you can coordinate it, and the BIM viewers are not able to, not now, I mean, they are sitting in the BIMFIT check somewhere over there and trying to get deal with the combination of different coordinate systems, but still they are not to show in one viewer different systems. This is not the way how they work. Here's an example what we did in Berlin. We choose the middle station and extended the width from 10 kilometers to 30 kilometers and had one system for the whole project. Any station is included. The distortion factor is almost 1, so it's not the big issue. Then BIM and GIS can cope very well together. This is the solution we would propose for how to do big infrastructure projects. Yeah, some points, as I told you already, just choose one. Just choose it if it's needed. Define when it's needed. For example, when you are close to the edge. And yeah, some technical things you need to document that, not only in the paper, but also in the IFC file. Obviously things, and then choose some reference points. It comes to the final question. I always ask, why do we do that stuff? Why do we project still? It's an old thing coming from Middle Age, paper. Ancient regimes like Egyptian paper, from that 2000 years old thing, we still use that. Why? The software tools are not thinking in a new way to, let's say, start with design process directly on the globe. Why do we use the map as a base? I don't know. It's technical, would be possible today, I would say. Of course, there are problems. Of course, it's complicated. You need to redefine any core of your software, I know, but think about it. It will solve a lot of problems. All the georeferencing points are gone when you just work, every one of us, on the same globe and as a real digital twin. Yeah, just as a picture of helping us software vendors understand that, provided for the engineers, it makes us simpler, the design, and then we can decide. Here is some information where you can read afterwards or try out by yourself, some checkers, validation, whatever, about georeferencing, interesting papers. And yeah, that's what happens. Okay, that's it. Thank you.
Thank you. Thank you, Paul. I don't know if you could leave the microphone. I just have a question. I know, Jim, you wanted to say something before the end, right? No? No, he doesn't. No, he doesn't. Okay. But maybe, Mark, you can help answer this question as well. I've been struggling a little bit with the EPSG codes inside the projected CRS This is a bit IFC nerdy stuff. But the EPSG code should be the combined EPSG code with both the horizontal and the vertical systems.
Yes.
But when I asked you, Mark, I couldn't find a way of getting those files into to ArcGIS properly. I'm not complaining. I'm just saying when we were half a year ago, we couldn't do this. And I asked you, and I think it's important that we start looking at these things in this three-dimensional world and not trying to combine 2D and 3D falsely or whatever you call it. But do you want to say something about the? No. Nah. Out of your.
Yeah, and I can give a couple of names.
It's below your pay grade.
Who are working on the validation service.
Yes.
To ensure that BIM authoring tools are. Okay, so the latest validation service does include tests. I think were the 4 groups that were involved to make sure that the 4.3 validation checks for georeferencing. It's not a requirement, it's a best practice in the validation tests. I can't answer your question specifically of why or how in ArcGIS you'd bring in that data.
Just wanted to get a comment. Okay. Yeah. Yeah, making conversation. Do you have any experiences from tests or whatever with the EPSG codes generally? I like them.
Yeah, it's running 3 doors here, the BIM fit check.
Yeah.
They are testing how to read EPSG codes out of IFC files and understand where it should be placed, even on the globe or in the viewer combined together. This is hard work for the software developers right now. They are complaining all the time about the wasted time, but at the end, the result is that they can read it directly from the IFC file and understand either rigid or the bottom way to understand, should I deform the geometry, the length, or should I keep the coordinates? This is what they need to understand at the end by technical and automated way and not by having a big document to read. And if you find an IFC file in 30 years and you don't know where the BIM execution plan is stored, it should be inside the file. Yeah.
Yes.
And the gap is not in IFC only. We also have like a preview for BCF. In BCF, you have the camera position. They have numbers as well, X, Y, Z, but nobody knows in what reference system it is mentioned to be. So could be a case to even implement BCF also for georeferencing.
Can I ask? Yes, sure, Mark.
Thank you, Karin, and thank you for the presentation. It was very impressive how you showed this difference between sea level example or the Alps. Huh? If you look at all the properties and so on, if you have the linear placement, it's very, very important that you not have the 2D plans and go on the linear placement for objects and functions and everything like that, just on the one-to-one relation. You have to really care about where your alignment is in the world. And so 20 meters is not the same on every height. And that we have to really to consider if we make a reference system for really a lot of other applications like in the train business, like ATO, automatic trains and everything like that. That's crucial that the people understand, and reference systems of all the infrastructure is considering that what you showed. Thank you very much for that.
Yeah, the problem is that the legal regulations and what the standards expect you to design are based on projected standards and not on the real one-to-one standards. So this need to be changed as well.
Sergey has a question, but I'd really like to ask a question to, or has an explanation or something. I just really want to ask a question to maybe Jan-Erik or Lee or some of the software vendors in here, because I think this is a key issue for us in infrastructure.
So first, a statement. This is actually the requirement is documented in IFC tunnel requirements analysis. So thanks for the great requirements analysis, and the solution was developed in IFC tunnel. So just to fix the acknowledgements a bit. I would like to ask, however, with these EP sets, on which entity would they then be to provide the entire semantic logic behind it?
It's based on IFC project, like the other EP sets already defined. They are on the high level, on the file level. It's proposed right now, and it's working like other EP sets already defined. So if there's a problem, it should be the problem there as well. So
I think
we
you
will
have
see.
something to talk about.
But we
Andreas,
can
we only
discuss
have
that.
2 minutes left.
Yeah.
Sorry.
I would propose that we take another path in the into a rather radical solution, essentially meaning that we get rid of this project focus. Yeah? If you look at infrastructure, you are typically combining different subsets over time at different boundaries. So get rid of this project focus. This would be the real thing which would be very helpful for infrastructure.
Thank you, Andreas.
It's
Can
just
I-
for
oh,
the
we've
exchange.
got
If
people
you all
with
work on the globe directly, then the project
I
is
open
just an
this
information, but
question
not
session?
not a limit. Yeah.
So this is, I'm from North America, and this is a question for my European colleagues. The way we've wrestled with this grid-to-ground problem is the owners specify the projection you're going to work in, and we have very specific projections that are geoid-based, gravity-based, that better supports GPS use. And again, tries to remove the distortion to an acceptable tolerance. So as soon as the design is handed over, you're already aligning to what GIS can use, et cetera. So I think that was something you were starting to say? No? Yeah?
Yeah, I didn't really get the question. What you have? I mean,
So I guess my question is that, I guess I was expecting the owners, the transportation industry or whoever within Europe, to be defining those specifications again to that tighter, so you don't have the grid to ground error as much.
yeah, there are some solutions. Some have 3-degree stripe width, like in Germany. In the Scandinavian countries, they only have 1-degree width, so they have a bit less distortion. Then the station system has 10 kilometers only, so quite slim. There is no, it's very different. And yeah, of course, you're right, but it's if you do that, you still project. And don't do that in the future. 20 years ahead of us, I know, but
Okay, I think you're off the hook, Lee and Jan-Erik. But we do have a question here. Yes, yeah, sure.
Sure. I have a question for you. Was it Cosiago? You showed the model with all the voxels and all the pieces, let's say. But is there any way to show where it's accurate or where it's not? Because between the boreholes, you have, of course, inaccurate data because you're interpolating. Are you showing that in the model or in a way that the people who are going to use it know how accurate that area is?
That's a very good question. So we made this model based on partly from boreholes. So as you said, in between boreholes, the data is kind of generated. And so there are some uncertainties there. And we talked about how to represent uncertainty in IFC 4.4, but I wasn't quite sure how to do it. Do you want to?
I can just say we have done something similar, but it's basically just defining where the bedrock is in a situation, and by making layers and coloring like the flat surface where it's accurate and where it's not, it's much more intuitive for the users to take part in that. But that's, of course, it's a flat thing.
Well, the uncertainty was definitely also a requirement, and it was proposed to model it as p-sets. That is never a good scenario, because how do you serialize that many p-sets? Then it's just about uncertainty in the file. But
So
it is a requirement, and it probably should be addressed at some point properly. So proposals open. You know, we're still in the phase. That's why we shared the links.
I think
Go for it.
Seg is going to be very busy during coffee break, because that's where we're at now. Could I just ask the steering committee to stay here just a few minutes for a couple of pictures or something? Yeah. Thank you all for attending today. It's been really exciting, and thank you for your input.